Welcome to the fourth week of the course Unit Operations of Particulate Matter. Now here we will start first lecture of week 4 and here we will discuss the topic flotation. This topic flotation is divided in two lectures, lecture 1 and lecture 2. In lecture 1 we will define the flotation, we will discuss applications of flotation process and we will discuss mechanism, its operation and flotation agents involved in the process. So, let us start the discussion on flotation. Now, what is flotation? If in general we will discuss what is flotation. Flotation is basically when something is floated over the fluid, something is moving over the fluid, that we call as the flotation. So, similarly in industry also this mechanism we apply to recover the valuable material from the gangue or from the minerals. Therefore, flotation represents the unit operation in which solids are separated from one another depending on their differences in surface characteristics. So, you see here because we want to separate the component from the bulk of component or from the bunch or from the bulk. So, some characteristic we need to separate, on which basis it should separate. So, here the surface characteristics of a compound of a material will be used to separate the material from the mixture. So, flotation is a unit operation which considers surface characteristics of a material to separate from the mixture or separate from the bulk of different component. So, flotation is a selective process for separating minerals from gangue by using surfactants and weighting agents. Now, here you see what what this statement says, that flotation is a selective process. What is the meaning of selective process? We are discussing flotation over here, and flotation separates the component, separates the material from the mixture on the basis of surface characteristic. So, what is the meaning of selective process? Because if we consider the mixture, it may have different material and they may carry same surface characteristic. So, among this we want one to separate. So, what should be, how we should select that which should be separated first, which should be separated second. To select that sequence, because we have to select the sequence of component and therefore it is called as selective process. So, we can say that if we have only two material, if we have only two material to be separated, it means there won't be any selective process, one will be separated from other easily. But if I have a mixture, I have to select I have to decide the sequence for the selection or for the separation. So, that sequence is basically, so based on that sequence we can say that flotation is a selective process if we deal with more than two component, more than two materials. And how we decide this sequence? That will be decided based on some flotation agents that we also called as surfactants, etc. So, that we will discuss later on. So, the selective separation of the mineral makes processing complex or economically feasible. So, whatever we are considering, that is the complex ore or complex mixture, and this selective process give a economic solution to that, because we can get the separation one by one after adding few surfactants or few agents, and that will not be that much costly. So, therefore, it is economically viable also. Now, as far as flotation application is concerned, the main application of this process is in ore dressing and mineral beneficiation process. How we go for ore dressing? this is the flow chart which speaks about recovery of metal from ores. So, if we say the ore dressing, what is the meaning of ore dressing is we have to separate the material which are involved in the ore. So, what should be the steps of this, that is shown through this diagram. So, first of all we have to take the ore from the mining, because that is the only source where ore is available. So, we will collect ore from mining and then we pre-treat over here. So, what is the meaning of pre-treatment? That when we collect the ore, it will have different sizes, some are of very large sizes. So, first of all we have to crush or grind these ores, and then the pre-treatment will be carried out. So, if we consider flotation process, it will help in pre-treatment. Pre-treatment can be done through flotation. So, here what is the desired ore, what we have to separate from the mixture of ores, that we have to select over here. So, here basically through flotation we separate ore from the mixture of ore. Once I am having the ore, then through chemical processing we can go for extraction of compounds, and then from compound to metal. So, if you see, if here if we want to extract the metal, for example, if I want to extract the iron, what I have to do, the ore of iron is hematite. So, that I have to recover in flotation process, and then from this we will recover iron through chemical processing, and that can be done in sponge iron process, because the metal iron, when we are considering, that is Fe, so that will be called as metallic iron or sponge iron. Now, once I am having this metal, we will go for refining and then for alloying. So, this is the flow chart of extraction of metal from ore and then preparation for alloys. Further, the flotation process is used for the separation of large range of sulfides, carbonates and oxides prior to further refinement, as we have discussed in this flow chart. So, phosphates and coal are also processed by flotation. So, here you see the main application of flotation is in ore dressing and recovery of metal from ore. And here we have some commercially important ore and associated metal. For example, if we want to separate copper, copper will be carried in chalcopyrite, and iron is in hematite. Lead, if we want to recover, for that we have to choose galena as a ore, and similarly we have many other, like if we want to separate zinc, we have to separate sphalerite from the mixture which I am getting from mining. Now, as far as operation of flotation is concerned, here through this slide I will speak about the operation which is involved in flotation. So, if you see this slide, here I am having material A and material B. So, to demonstrate the flotation process, I am considering binary mixture, and here as far as material is concerned, we have taken material A as well as B. These materials should be mixed before starting the operation. So, where A is hydrophilic and B is hydrophobic. So, if you remember the flotation process separate the compound, separate the component based on surface characteristics. So, surface characteristics should be such that it should accept water or it should repel the water. So, based on that only we separate in the flotation process. So, in this case, if A is hydrophilic you understand, which accepts the water, and component B is hydrophobic, which repels the water, and the complete mixture of A and B is carried in a flotation medium, and the medium should be water and air, because one is hydrophilic and another is hydrophobic. So, we have to take water along with air, and that complete mixture will be agitated vigorously. So, once I am having this mixture A and B in the flotation medium, what will happen after some time? If you see here, if I am having the material A and material A is its surface characteristic is like that, it accepts the water. So, after some time what will happen, it will have the water layer over its surface. So, like this it has the skin of water. Now, what happens with the component B? Because component B is not accepting the water, another component in the mixture I am having is air. So, it will be accepting the air bubbles. So, after some time what happens, at the surface of material B, air bubble will be formed. So, around a film of water will be there and around B air bubbles are there. So, what is this compound? This is basically solid plus water, and what is this compound? This is basically solid plus air. So, if we are considering the aggregative density, so density of this A and water should be higher in comparison to density of B and air, because density of air is very less in comparison to that of water. So, obviously component A with the water film over here become heavier in comparison to B plus bubbles. So, component A will be settled down due to its heaviness, and component B along with air bubble will be floated up. So, because of this, that component B is floating with the help of air bubble, the complete process is known as flotation. So, once the component is floated, and here we have collection of material B with air bubble, and this combinedly we call as concentrate, and similarly material A and water film will be collected at the bottom, and that we have taken as tailing. So, you see concentrate is prepared with the floating compound, whereas tailing is prepared with the compound which sinks. So, this is the basic operation of flotation. Now, here we are discussing froth flotation. Now, what is froth flotation? If you remember the last slide, we have discussed that component B floats because air bubbles are formed over its surface. Now, when we have this air bubble and different particles of compound B carry air bubble over this, and all this will be floated at the top. So, at the top of the flotation cell or flotation equipment, the froth will be available. So, therefore, this process is called as froth flotation. Since flotation separates material by virtue of their differences in surface characteristics, separation can be affected regardless of their densities. So, the density of the compound will not affect the separation process, only surface characteristics of the compound will matter. So, froth flotation commences by comminution, which is used to break the rocks into desired minerals and to increase the surface area of ore for subsequent processing. So, first of all we have to crush or grind the mineral, grind the rock, and then the small particle of that will be used for flotation process. So, the desired material is rendered hydrophobic by the addition of a surfactant or collector chemical. The particular chemical depends on the mineral being refined. As an example, pine oil is used to extract copper. So, here you see some surfactants we are using for changing the characteristic, changing the surface characteristic of the compound, and this surfactant will depend on different compound. Like same surfactant cannot be used for changing the surface characteristics for all, otherwise all will be floated. So, it would be selective. So, surfactant would be based on what component we have to separate. So, surfactant is chosen based on what component we want to float or we want to separate. Now, as far as flotation mechanism is concerned, you see what happens when we are considering the mechanism. When material will be float, when air bubble will be available at its surface. So, when water layer will be available at surface, it will not float. So, what happens, there are basically three phases. First is water, then air and then solid, all three phases, and mechanism of flotation can be illustrated, can be discussed while considering all these phases. So, flotation depends on relative adsorption or wetting of the solid by fluid. This is controlled by surface or interfacial energy or interfacial tension. So, you see solid basically attracts water or attracts air bubble. So, in that case the surface tension will play an important role, so that the bubble will be attached to this or film will be attached to the solid. So, if solid is easily and completely wetted by water, as you see this figure, here we have the solid and this is the air bubble, and in between water layer is there. So, if the solid is easily and completely wetted by water, the liquid will exist as a skin between solid and air, and there is no point of contact of three phases. So, when we are considering this case where water is available between air and solid, so we can say that contact angle of air as well as solid is 0, and once this contact angle is 0, solid will not float. So, if the surface of solid is not completely wetted, if the surface of solid is not completely wetted, it means some of the portion is covered by the air bubble. The liquid is forced to move an equilibrium position where the surface tension forces at the three interface are in balance. So, you see here we have three surface tension. First is between solid and liquid, and then we have between gas and liquid after having contact angle that is theta, and another surface tension we have between solid and gas. So, once we want to balance over here, it should be like this: solid between solid and gas, the surface tension is sigma Sg, and that should be equal to sigma Sl plus sigma Gl cos theta. So, this is basically the balance of forces, and this forces is caused due to surface tension. So, here you see theta is an important factor as far as bubble formation is concerned. So, if bubble formation will be large, theta will also be large, and if theta would be large, it means floatability should be enhanced. So, if the contact angle is small, liquid will advance over the surface of the solid, since the surface forces holding the bubble and liquid together will be weak. So, when contact angle will be lesser, so after some agitation, after some vigorous agitation, bubble can be separated from the solid and liquid will enter between solid and bubble. So, it will reduce the wettability. So, if we want compound to be floated, the contact angle should be large, and this contact angle is between air bubble as well as solid. So, large contact angle therefore indicates easy floatability, as we have just discussed. Now, what happens when air bubble is formed on the solid surface? What happens? It takes some energy from the solid. So, when air bubble is formed over solid surface, some energy will be released from solid to air bubble. So, and that loss of energy will be nothing but in terms of surface tension. So, the loss of energy that we represent as minus delta E is a measure of wettability of the solid by air, and therefore an indication of the floatability. Further, if the magnitude of this work is large, it means a lot of work is to be expended for detaching the bubble. Now, how this work come into the picture? Because we are considering the energy which is lost from solid to air. Now, what happens when this energy will be large? We have to put more effort to detach this bubble from the solid. So, in terms of that, work comes into the picture. So, if the magnitude of work is large, it means lots of work is to be expended for detaching the bubble from the solid surface or from decreasing the air solid interface. In other words, the air solid contact is quite strong, and therefore floatability of the solid is large. And if we want to make the expression of energy mathematically, how we can represent, because when air bubble is formed on the solid, energy is released from solid to air. So when we are considering total energy of the solid, the balance should be in terms of sigma SL, that is between solid and layer, plus sigma GL, because that is positive energy. However, energy will be released when air bubble is formed, and therefore this sigma SG will be considered through negative sign. Now, considering previous equation and this equation, we can further correlate loss of energy per unit surface as sigma GL1 minus cos theta. So, you see here theta, when we are considering, as we are having more and more theta, more value of theta, it means cos theta would be reduced, this factor will increase, and then surface energy and then energy loss from the surface will be increased. So, once energy loss will be increased, it means the solid can be floated easily. So, large angle will speak about good floatability. So, that is the mechanism of flotation process. It can be based on surface tension. So, here we are discussing the flotation agents, because this is the selective process. When binary mixture we are considering, there is no need for adding any agent, because one will float and another will sink. But if I am dealing with the mixture and that is generally seen in rock which is recovered through mineral, it has many compound. So, we should go for the selective flotation, and when I am going to selective flotation, I have to add some flotation agents to change the characteristics, to change the surface characteristic of some compound, so that it can be floated and others should not. So, there are different flotation agents. First agent we call as collectors and promoters. So, the primary flotation agents are collectors and promoters. These are adsorbed selectively on the solid surface, forming a thin film on the surface of the solid. The solid surface is thus made hydrophobic, that is water repellent, and therefore will be little wetted by water. Contact angle is increased, and so is the floatability. So, what is the purpose of collectors and promoters? They change the surface characteristic of a compound in such a way so that it becomes water repellent, and once it becomes water repellent, it can attract air bubble over there, and then the flotation will be carried out. So, a sharp distinction between collector and promoter is difficult. However, we can say that promoters generally prepare a monomolecular layer on the surface, whereas collectors form films that are several molecules thick. So, that is the only difference, otherwise collector and promoter work in a same manner. Petroleum is an example of true collector. Other collectors are pine oil and salicylic acid. The most commonly used promoters are xanthate, aerofloats and thiocarbamylide. So, here we will see the mechanism of sodium xanthate, so that you can understand what happens. Here we have sodium xanthate, that is NaSCSOR. So, if you consider this compound here, the R group which is available over here, that works as a water repellent group, and this is alkyl or amyl group, it works as water repellent. Xanthate radical, that is SCS, is solidophilic group which causes adhesion to the mineral surface, and ONA group is non-water repellent. So, you see here we have three different group. In among these three different group, only R is the group which makes the compound water repellent, and ONA will not be a water repellent group. So, when this compound, that is sodium xanthate, come into contact with the solid, the ONA compound will be at the innermost, because that is water repellent, and R compound should be at outermost level, because it makes the whole compound as water repellent. Further, for the beneficiation of sulphide ore, xanthate are most popular. So, when we have to recover sulphide ore, we should use xanthates. However, xanthates are dissociated by strong acids and therefore they are not usually used when the pH of the medium is less than 7. An exception we can have is the flotation of pyrites, which is done in slightly acidic medium. So for pyrite we can use xanthate, and the pH of the medium and pH of the medium should be towards acidic side. That is the exception as far as xanthate is concerned. Now as far as quality of collectors or promoters are concerned, it is used in 0.01 to 0.1 kg per ton of solid. So that amount is not very significant, and therefore when we are using these agents, even then the economy of the process will not be very high. Another agent we have is the frother, because while using the collector we prepare the surface of the metal, we prepare the surface of the solid as hydrophobic, and now we will add the frothers. So what is the purpose of frother? Frother is basically when we are using the frother, it gives stability of the bubble. It means it won't allow bubble to separate from the solid or bubble to break. So frothers are used to attach the bubble to the solid surface. So once I am using the collector, it helps to prepare the surface hydrophobic, and therefore air bubble can be found over the surface, and then this frother becomes a layer between air bubble and liquid, and so that liquid cannot be entered over here, and then the stability of the bubble will be ensured. So frothers help to maintain a persistent froth. They get adsorbed on the air water interface and thus reducing the surface tension of the water. Higher alcohols, that is hexyl and octyl alcohols, are good frothers. So these are some example of the frothers. Pine oil or eucalyptus oil are also widely used as good frothing agents. Salicylic acid, though it is a good frother, it produces an unsatisfactory brittle froth unless used with the trace of petroleum. So we can use salicylic acid with petroleum as a frother. Now as far as quantity is concerned, it is used in 0.025 to 0.15 kg per ton of solid. So in this range it is used. Next flotation agent we have is the modifiers. Now what is the purpose of modifier? These are used in selective flotation when more than one material is to be floated off. So here you see, when we are having the mixture of compound and we have to separate these compound one by one, so we have to decide the sequence in which they should be floated off. So among the whole material, only one we should float off, other we should not. So how we can do that? By adding modifiers, only compound which we want that should be floated off, other would be depressed. So modifier is basically providing the activity, or so modifiers are basically used to activate or depress a material. Now how it does? They are reagents that react with the surface of solid either by chemical action or by adsorption, thus alter the surface characteristics so that the adsorption of the filming agent, that is collector or promoter, is activated or depressed. So by chemical means, by chemical reaction or by adsorption, it changes the surface characteristic of one compound and make it accessible for collectors as well as promoters. So here we have few example. Copper sulphate, if I am using, copper sulphate activates the surface of sphalerite due to formation of copper sulphide on its surface. If copper sulphate is used in excess, it also activates pyrite. So copper sulphate is used to activate sphalerite, and when we are using in more amount, pyrite should also be activated through this. And sodium cyanide is a depressant to pyrite when it is present with galena, and zinc sulphide is depressant to sphalerite. So you see here, when we are having the mixture, we can activate only one compound and others should be depressed by adding some modifiers. Further, dichromates are depressant to galena. Sodium sulfide or sulfuric acid is used to activate pyrite that has been depressed in the previous flotation. If I am using pyrite with galena and sphalerite, we can use sodium cyanide to depress pyrite. So, galena should be floated off, and because we have already depressed it, it should be activated by adding sodium sulfide. So, by this way modifiers work. Another modifier I am having is the pH controllers. If you see, this is the table where I am having different critical pH for the compound, and for example, if I am considering sphalerite and we are using collector as potassium di, and if we are using this as a collector, the critical pH of medium for sphalerite to be floated off is 10.4. So, if I am making the pH of the medium more than this, so sphalerite should be floated off. So, there exists a critical pH of the medium corresponding to any given mineral, below which only the mineral will float when a specific amount of a collector or promoter is used, as we have just discussed through this table with the example of sphalerite. So, pH controller is used as a modifier. Another frothing agent is the dispersing agent. These are used to break up agglomeration of minerals and gangue. Example: sodium silicate, sodium metaphosphate, citric acid and soluble starch. These are the dispersing agents. Now, once we are using different flotation agent, what happen with the material? You can see this figure here. At the center we have the particle, and when we are using collector and before this, before collector we should use the modifier if I am having the mixture. So, that modifier changes the surface characteristic as we have discussed. Once I am having a particle, we will add collectors over here, and if you remember, the xanthate radical of the collector is used to join particle as well as collector. It will be placed over the particle, and over this xanthate radical we have R group, because R group makes the whole particle as water repellent. Once it is making the particle water repellent, air bubbles are formed over here, and stability of these air bubbles can be ensured by adding frothers. So, frother layer should be outermost. So, in this way each agent will associate with the particle. Now, once it will be floated off, we have the froth. So, after the removal of froth, it must be broken as completely as possible to recover the mineral present in it, which is done by strong jet of water or by passing through a thickener or centrifuge or by subjecting the froth to high frequency sound wave. So, here you see we have discussed different flotation agent which take part in the process, flotation process, and this lecture we are stopping over here. We will continue discussion on flotation process in the next lecture. So, that is all for now. Thank you.